Excited about AlphaTensor, a new paper by DeepMind published in Nature explains how DeepMind using the AlphaGoZero algorithm and tweaking it to the problem of matrix multiplication has delivered actually a better way to multiply matrices. Now, this has two massive implications. One, improving matrix multiplication is at the core of almost every scientific problem, in particular the artificial intelligence problem, which is very heavily driven by matrix multiplication. So improving matrix multiplication can absolutely improve science and AI and computer science in particular. Second, I think it's obviously very, very encouraging to see an application coming from AlphaGoZero, which was meant to be trained to play Go, and then be translated into a mathematics problem. And I think this really opens up the horizon of the possibilities that reinforcement learning and in particular this DeepMind approach has to any kind of scientific solution. I think for us, the Orange Capital Partners, this is incredibly encouraging, particularly in times like this when we're looking at declining share prices. Our performance is dismal. We're now down 47%, 47.8% to be precise. This is terrible. It's one of the worst performances of the year. We have had even worse numbers, but nevertheless, it is very encouraging to see how science, innovation, how fundamentally new concepts in engineering practice really can take hold. And it's the mission of our fund to generate wealth by investing in fundamental new concepts and engineering practices. So this DeepMind approach is a beautiful example of how our mission is not just some sort of dream, but it is actually real. It's happening. And it is our job to employ our capital to projects that can employ fundamental new concepts in engineering practices. This is not even wrong podcast. It's October 11th, 2022. This is Krimdelko. For the day, the fund is down 1.7%. The market is down 70 basis points. For the year, we're down 47.8%. The market is down 25.6%. We're underperforming by 22.2%. Introduce a paper that DeepMind recently published in Nature. It's AlphaTensor. And AlphaTensor is a learning model that is helping find better algorithms to do matrix multiplication. So it's not doing matrix multiplication per se. It's finding an algorithm that can do matrix multiplication faster than the algorithms that we know already. And the key is that it's being done through reinforcement learning. They use to play Go, and it's applying the same concept to another problem, which is matrix multiplication. So there's a translation from one domain to the other using the same model, which is very powerful. I think it's also showing that you can characterize a mathematics problem such as matrix multiplication within the context of a game, which I think is unbelievably powerful. It is my belief, it is my conjecture that every kind of problem can be represented as a game. In fact, solving problems is a game. This is a very powerful statement. And DeepMind, by using reinforcement learning to solve different types of problems, is proving that. Marrying, having a good marriage, whatever problem you throw at in life, it is a game, and therefore can be represented in some sort of reinforcement learning architecture. This is important. So the reinforcement learning architecture that DeepMind is using playing Go with AlphaGoZero is just the base of a much deeper and much more fundamentally impactful architecture that can be used for pretty much anything in the world. at least within the problem space as we know it right now. We might, over time, create new problems in a Popperian way by solving some of the most excuse me, by solving some of the most fundamental problems. We could create new problems that might have different types of representation and architectures to solve them. But nevertheless, as we speak now, we're living in a space where we can use reinforcement learning or game theoretic approaches towards the solution. So this is very powerful. I think another very interesting learning from AlphaTensor is that we've said many times in this podcast that math or computation is the best way to iterate and find solutions to counterfactuals, because whatever we call knowledge in the end is an exploration of counterfactuals. This is my point. So exploration of counterfactuals, all right? We look at the world and information is hidden in counterfactuals, and exploring those counterfactuals is revealing information, and revealing information helps us use intelligence to solve problems. Now, computation is just accelerating that. And what AlphaTensor shows is actually the other way around, which is that iteration and the representation of a problem within the context of reinforcement learning can help accelerate computation, and therefore also help accelerate finding a solution for, let's say, finding a better algorithm to actually accelerate the computation. So there's a recursive, almost Escherian thing going on here, where we have a model, the reinforcement learning model, helping improve computation, and we can use that improved computation to then improve the reinforcement learning model. So this is very powerful. This is very deep, and I think this is what DeepMind is after, and that's why we're so excited about this paper. I wanted to just bring this out because it shows that we have I think this is an ImageNet moment to paraphrase one of the analysts. I forgot his name now, put in the show notes. He said that this could be an ImageNet moment where we are finding a real application for something that was playing Go, AlphaGoZero. It was all play, it was all fun, but now it's becoming real. Because matrix multiplication, again, it's at the core of many, many scientific applications of. Again, I mean, I can't emphasize enough how important this is, that you have a reinforcement learning problem which is applied to a game of Go, and now you're applying this same architecture to the problem of finding a faster algorithm for matrix multiplication. This is a proof that every solution as to solving problems is a game, and therefore reinforcement learning can be used as is the most optimal representation of that solution of a problem. Therefore, that's why these neural nets work so well. The reinforcement learning architecture of DeepMind works so well. The game, this also explains why people are so excited about playing games. Why are teenagers playing games? Why are humans so excited about sports? Because solving problems is a game. Most excited when we're at our most natural, and our most natural is to use intelligence to solve problems, and intelligence is a game, is playing a game. DeepMind is so powerful. Now, for us, Orange Capital Partners, we don't have any investment in DeepMind, nor do we have any investments in anything close to what they do. However, we're invested in Tesla, which is attacking a very important intelligence problem, which is driving. It's not a very difficult problem compared to maybe other problems. Nevertheless, it's still a very difficult and important problem. And if we can use a game approach, reinforcement learning approach towards that problem, I believe we have a better solution. This is why we're encouraging Tesla to get involved with DeepMind, either directly or indirectly, at least use their models, work with AlphaGoZero, MuZero, whatever, AlphaTensor. Those are all interesting applications of the same concept. So this is incredibly powerful. This is almost an extension to David Deutsch and Popper. Solving problems. Science is about solving problems. Science is a game. And we can use a game architecture such as reinforcement learning to attack scientific problems. In fact, we can use reinforcement learning to attack anything which at the core is trying to solve a problem. So intelligence is the exploration of counterfactuals to solve a problem. And the exploration of counterfactuals can be done most efficiently in form of a game. To summarize, the paper by DeepMind, AlphaTensor, is on the one hand a beautiful example of how we can use reinforcement learning to find a better algorithm to do matrix multiplication. So we can use a model which was used in playing Go in a game to apply to another domain, which is mathematics. But more importantly, a lot deeper, this shows this is the path towards redefining intelligence. Intelligence is playing a game. Solving problems is a game. And therefore, we can use a game-like architecture to get solutions to the problem. And reinforcement learning is the best we know so far. There's others. Adversarial networks, for example, are kind of game-like structures. But this is a very powerful thing. And I think the recursiveness here is also interesting. So we use a reinforcement learning model to improve matrix multiplication. We can use that to then improve the model again and then improve the matrix multiplication. Another thing that comes from this paper, and this is one of those gifts that just keeps on giving, which is that as far as we know, humans, as the way we evolved through centuries, is through the using games to solve problems. That doesn't mean that every problem that the universe throws at us is a game. There could be that if we get to the level of intelligence to solve a lot of the fundamental problems that we know as humans, that we can get to another sort of problem space that is not gameish. That is a conjecture, of course, that I can't prove right now. This is almost like another multiverse that we don't know now because we're too much in the dimension of the game type problem-solving world that we live in. But this is an interesting point. But the most interesting thing, again, is that solving problems is a game. Using game theoretic approaches or reinforcement learning approaches, which are funded in or which are founded in or grounded in game theoretic type approaches, is the best way towards finding intelligent ways to solve problems. Intelligence is solving problems, and DeepMind is showing all of these things with this paper that they published in Nature, AlphaTensor.